3.4, multiplying signed fractions. Well, we've kind of been doing that with the prime factorization, actually. And one way I'm going to show this, right? So we saw that, let me make that a better A times B over C times B. It was just A over C, right? Excuse me. But that could have been shown as two separate fractions like this. So if you wanted to, you could say, well, it's A over C times B over B. It's the same thing as this stuff, okay? And again, we'll see that in the explanation as well. Now, one way to think about this, and we don't require that you do think about it like this, but it hopefully helps us to understand what the crap is going on here. So multiplication is just simplified addition, right? Now, it would be kind of difficult to demonstrate that with multiplication of fractions. So that's what it is. It's just kind of hard to show with fractions. So if we said multiplication is the result of how many groups of something else there are, that makes more sense with the multiplication, because in this specific example, right, I got half of 3/4. So I would want to demonstrate this with a diagram. And again, I would say, well, this is a pan of brownies. So I would have 3/4 of a pan of brownies, right? So that's these three pieces right there. And I would like 3/4 of a pan of brownies. I would love that, especially if I had chocolate chips. But I only want half of it. It's a half group of that 3/4. So I'm going to cut this thing in half, and I could cut each of the individual pieces in half vertically, but it's going to be easier for me just to cut it in half this way. Well, if I cut that in half of it now represents these three pieces, right? So that's three pieces, and what size are the pieces now? Well, how many pieces are there? There's 1, 2, 3, 4, 5, 6, 7, 8 pieces. So that would be considered 3/8. The multiplication of this is 3/8. Now that diagram, maybe some of you guys hate the diagram, and that's okay. We don't require that you use diagrams. But you may see a relationship between the multiplication problem and the answer that we got there as 3/8. So just take a moment. Some of you noticed what happened in that last problem with the multiplication. See if you can figure out the product of 4/7 and 4/5. All right, we'll give you 1 minute to see if you can figure this one out. Again, if you make mistakes, it's good. We're just practicing right now, and then we can learn from our mistakes, okay? 1 minute, go. All right. Well, this would be the answer, you guys. And we'll demonstrate why here in just a second, if this will write. Now, this is what you should have gotten out of this problem, right? 16/35. Now, again, sevenths and fifths, that'd be pretty difficult to show on a diagram, so I'm not going to do it. Plus, it would make it probably more complicated than it needs to be. What you should have noticed from that last problem is all we really did is we took the numerators and multiplied them together. 4 times 4 equals 16. And 7 times 5 equals 35. Okay, just like on that last problem, 1/2 times 3/4, 1 times 3 is 3, 2 times 4 is 8, and the answer to that one was 3/8. Okay, so that's all multiplication of fractions is. You just take the numerators, multiply them, the denominators, and multiply those. And this just shows this abstractly, right? Again, I'm not using numbers, I'm just using letters, which would represent numbers in a situation, right? Like this be 4/7 and what was the other one? 4/3, 4/5 or something like that. So A times C, that's our numerator, and then the denominators multiplied together, that's the new numerator. So this one, multiply and then simplify if it is necessary. Okay, well, we can do that. It's not too bad. And for the next problem, I'll show it a different way, actually. Well, I have to make up my own maybe. All right, any case. So you're just using that strategy as is, right? So the first thing on this one that we want you to notice is that there's only one negative being multiplied. One is odd, so I know the answer to this one is negative. And we should get a fraction. Well, then I'm just going to multiply my two numerators. 6 times 5 is 30. And 5 times 8 in the denominators is 40. Now, it did say simplify if necessary. It's not always necessary to simplify if it's in lowest terms. And simplification is considered lowest terms. And this one is not in lowest terms because I know 30 and 40 can be simplified, right? Well, what can I simplify 30 and 40 by? And yeah, some of you guys would just cross out those zeros. Others of you would divide both of them by 10, and that would work. Which would then give us not 3/4, because we need to remember that negative is still part of the answer right here. Now, negative 3/4 can't be simplified any further. And you may ask, well, how do you know that? Well, I mean, other than just doing math, more math than any human really should do, is I just typed in the calculator, right? Well, negative 3/4, and then I push enter, bam, it equals negative 3/4. It's the same thing, which means it's fully simplified. Well, doesn't that mean you could have done that with the negative 30/40? Yeah, you could have. You could have typed in negative 30/40 right there like that, and it would have simplified it for you. Remember? We did talk about that, right, in the last section. So, there's a couple strategies for simplifying these. There's something else that we should remember, or another strategy that will come in pretty handy, okay? And that is cross simplification. So we can see, and both of these are demonstrating the same thing, just some have more letters, right? Like over here on this one, in the top, I have a C in the numerators being multiplied, and a C in the denominators being multiplied. And what that means is I can simplify by making those C's a phantom 1 right now. And then I don't need to worry about multiplying by that C in the numerator or denominator. All I would do is multiply A and G and D and H in this example. Also abstractly in the bottom here, the B's would be considered cross-simplified. Alright, so after I cross-simplify those by making the B's a phantom 1, then I just would have A over C, which would be great. Okay, and that makes things a lot easier. Now, there's a third method, which we're going to get into. But right now, I want you guys to think about this cross-simplification stuff. So, like this one right here, right? And the cross-simplification comes in pretty handy, especially if you're using prime factorization, okay? So, that 3, it's not just 3, okay? Because this is multiplication of fractions. That's the name of this section of this module. So I needed the 3 to be a fraction. I just make it a 3 over 1. So remember, again, if you're not seeing a denominator, just make it up. Just put it as divide by 1, okay? It needs to be 1. Don't just make up any number. So you can show it as divide by 1, right? Now, if I were to use cross-simplification on this one, I would probably take that 12 and split it up into its prime factors. Now, again, it's not necessary that you split it up into its prime factors, because I know 12 could split it up into 3 and 4, right? 3 times 4. So if I were to rewrite this, I'd have 3 over 1 times 5 over 3 times 4. Well, see how I have a 3 in the numerator and 3 in the denominator? We'd just be multiplying those together, but that would add a few extra steps to the problem. See, now in the numerator I just have a 5, and the denominator 1 times 4 is just 4. So it ended up being simplified, in this case 5/4, which would be the final answer. But keep in mind that sometimes we may not have fully simplified the problem with cross-simplification, all right? But this is how cross-simplification works, just like simplifying fractions into equivalent fractions would work, okay? Oh, I should mention, if you guys are using prime factorization for all of the values, then you will end up with a fully simplified problem with cross simplification. But again, there is another method. So again, if I were to use cross simplification on a problem like this, we'll get to the third method here in a moment. Well, even before cross simplification, for any problem multiplying fractions, you should look for how many negatives are being multiplied together. And again, I see two negatives being multiplied, which means my answer is a positive. And since it's positive, again, I know I can just ignore those negatives and work from there. Now, cross simplification means that we can cross simplify with other fractions. So, the first thing I did notice, was the 2 and 20 are both divisible by 2, right? So I would say, well, 2 divided by 2 is 1. So now that value is a 1. And I've crossed out the 2, so it's cross simplification, right? 20 divided by 2 is now 10. So I've replaced those values with the values I've written in. But the 7 and 21 is also simplifiable. 7 and 21 can be simplified by 7. 7 divided by 7 is 1. 21 divided by 7 is 3. And now I have two fractions that I can multiply, which should be a lot easier. 1/10 times 1/3. Now, if you think about what we just did right there, specifically because these ones have parentheses, right? So, like on this one, by simplifying these fractions kind of like this way, it's almost like we just use the order of operations, almost. Okay, because we could have used the commutative property to move this 2 over here and the 7. We could have switched those values with their placements. Maybe that made things worse. But in any case, now I have two fractions that are pretty well simplified that I can multiply. Again, I've got 1 times 1. The numerators is 1. And the denominators, 10 times 3 is 30. Now again, we already knew that the answer was positive. So I don't really need to show that sign, but it's just 1/30 is our answer. But there is another way. So yeah, if we were to show this one just with the classic multiplication of fractions, and again, we don't require that you cross-simplify or use this classic method of just multiplying these out, right? So the first thing, again, I would just notice, again, two negatives multiplied together, 2 is even. So I know my answer is positive. But yeah, then you got the 7 times 2, which is 14. And then 20 times 21, I would just put that in the calculator to get 420, right? Now this is all positive. Now at this point we need to look and see, well, what can I simplify 14 and 420 by? Or you could use prime factorization, all right? You know what, which one do you guys want me to use? And again, it doesn't matter which way you use. You could have used scale factors where you know 14 and 420 are divided by 2 and use that method. But prime factors is also a valid method. So that's what we're going to do, okay? So 14, that one splits up. It's pretty easy. Just 7 times 2, right? 420 is a little bit, maybe a little bit more complicated. I know it ends with a 0, so it's divisible by 10. 10 times 42 would be 420. 10 splits up into 5 times 2. Both of which are prime. 42, though, splits up into, I would say, 7 and 6. And 7 is prime, and 6 would split up into 3 and 2. So I'm going to list those out. I had 5 times 2 times 7 times 3 times 2. So now I'm looking to simplify, just like we were with fractions in the previous section. Just finding any matches, right? And right there I got a set of 2's matched. But I also have this set of 7's which match. So simplifying this fraction, that's as far as I can go, right? Because I don't even have anything left in the numerator to simplify with. So I need to show that it's just a phantom 1. I'm changing the phantom 1 into a visible 1. And then I multiply the values that remain or weren't crossed out in the denominator. So 5 times 2 is 10. Times 3 is 30. And you can see we get the same answer, right? Now, let's go back to that 14 420. So let me show you guys that scale factor stuff, okay? And you don't have to memorize the names of each of the methods or strategies. They're just strategies, okay? So you can call it whatever you want. But this one, again, I said 14 and 420. I can see they're both even. So I'd probably start by dividing both of these by 2. 14 divided by 2 is 7. And then 420 divided by 2 would be 210. Well, then I see 7 and 210, focusing specifically on the 7 and 21, right? Both of those I can see are divisible by 7. 21 is divisible by 7, and same with 7. So I should be able to divide both of these by 7. 7 divided by 7 is 1. 210 divided by 7 is 30. And again, this is just a third method that shows that we get the same answer, but using a different method. So this one used all three. Cross simplification, we used scale factors, and we also used, we used prime factorization. That was the second one in green. And then we used scale factors. But again, I'm just going to point this out. There is a fourth method now. Fourth method, right? I'm glad you bring that up because, again, these are just methods. I'm not saying even that one's better than the other. I could certainly say that one's shorter than the other. Like, you can do one faster, but like if you're like, you know what, that second and third method, man, I know that I feel comfortable doing those ones. Man, you do it, man. And if you wanted to try the cross simplification just to try to get used to it because you feel like it is easier or faster, you're welcome to do it. But again, it's not a requirement. I don't remember seeing any on the quiz for this module that say you have to use a specific method. And even if they did, it's like, well, how are we going to know for sure? I mean, you're the only one that can know that, okay? So I'm not trying to keep you guys in suspense here. It's not like it's an action movie where you guys aren't sure how it's going to end, or maybe there's some kind of betrayal at the end. There's none here, okay? It's just another strategy. But let's analyze this one. We'll show both methods for this one. What the heck? But the first one is just to expand a fraction like this one, okay? What I mean by that is instead of showing it with an exponent, I want to show this with repeated multiplication. So that would be negative 4/7 times negative 4/7. Well, on this one, again, I can see I got two negatives being multiplied. And then I can multiply the numerators. 4 times 4 is 16. And 7 times 7 is 49. And you may wonder why I did not even look to cross simplify. And that's because we could have looked at the original fraction. And I know 4 and 7 can't be simplified, 4/7. So that means that with an exponent like this, it's not going to have any other prime factors that can suddenly be simplified. Okay, so I can just multiply this one. 4 times 4 is 16. 7 times 7 is 49. And feel pretty confident that this is my final answer. Alright, so let's look at the fourth method. And I'm just going to use cross simplification first. Alright, just so we can compare the two. And again, you can choose which one you like the best. I like the fourth method the best. I show the one I like the best last, of course. Otherwise, we end up using it usually all the time. But for cross simplification on this one, the 5's just cancel out directly as phantom 1s. And then I would notice the 4 and 2 would simplify. They're both divisible by 2. And I don't really see anything else I could simplify at this point. Other than maybe the negatives, right? Like I got two negatives being multiplied in this case. 2 is even, so I know my answer is positive, and that's good. So I'm just looking at the numerators. I got 2 times 1, which is 2. And the denominator is 9 times 1, which is 9. And that would be simplified. Now, that may have looked more complicated in the beginning because there were 3 numbers being multiplied, but the concept still remains the same. And if you use one of the other methods, right, like 5 times 4 times 1, well, that's 20. And then 9 times 5 times 2 is 90. And 20 over 90 would still simplify into 2/9. But the fourth method is where we just... And I'm I'm not really being sarcastic here. I'm being serious. We want you to use a calculator, okay? So the fourth method is to use the calculator. And I can type this in exactly like I see it. All right, next up, we'll find the area of this triangle. All right, so they've given us a formula right there. The area of a triangle is 1/2 times the base times the height. Now, just so we understand for triangles, and it doesn't matter if it's kind of a old-fashioned triangle like this one. It can be acute. From time to time, we may see an obtuse one like this one. But the base is always just, I guess, in these types of drawings, it's that bottom value. So this one, the base is this one. But the base should always create a 90-degree angle with the dashed line, which shows the height. All right, so the height, just trying to color code this, is this dashed line right there. Okay, now for an obtuse triangle like this one, it's going to be shown over here. And again, it's just a matter of making a 90-degree angle with that base. Okay, so this is the height. Over here would be shown right here. That's considered the height. And then the base would be this one. Right? It's half of the base and the height, because a triangle is a half of a parallelogram, and we don't really have to understand that completely. Just understand that that's where the half comes from. So for the area of a triangle, I got 1/2 times the base. Now again, the base needs to create a 90-degree angle like this one does with the height. It's also known as the altitude. Not that we care, but the base in this one shows it is 10, right? Shows it right there. And the height is that red line, which shows as 9. So I got 1/2 times 10 times 9. And again, for me, I would just type this into the calculator. I got 1/2 times 10 times 9. And again, not everyone needs a calculator. I would definitely recommend using one to check. But if you did that in your head, that's okay. Just make sure you're checking your work. So I got 45 out of that. Now, generally speaking, for area, we would want to label this. But it didn't tell us what the units were. So we'll just leave this as 45. Otherwise, we may label it as like square units or something like that. So another way to do it is, just like you said, where you take the base and multiply it by the height and then divide by 2. I guess part of that is just we haven't really gotten into dividing fractions yet. I mean, dividing by 2 really isn't too bad, but yeah, you definitely could have written it like that, where you took the base and the height and just put it in like this. Now that that's been brought up, I want to point something out about that, is multiplying by 1/2 and dividing by 2, it's the same thing, right? It's like saying if we multiplied by 1/4, it's the same thing as dividing by 4. And that is true, all right? So this creates kind of a fact family with multiplication and division, or at least a relationship between the two, which we should be able to understand, hopefully by now. All right, if there are 7,419 students at Rocky Mountain College and 1/3 of the students take economics, how many students take economics at Rocky Mountain College? You know, you guys take 1 minute and see if you guys can solve this one, then we'll go over it, all right? 1 minute, go. Now, I'm going to just kind of go through this again, right? There are this many students at this college, and 1/3 of them take economics. So how many of them take economics? Well, it's 1/3 of the 7,419, right? So it's like saying I got 1/3 of a group of 7,419, all right? Which is why this is multiplication. The other reason why it's multiplication is because the name of this section is multiplication of fractions. Now, that's not going to be that clear on a test, so it's important to understand why we're multiplying, other than just to know that that's the section we're on, okay? So, for this one, we're just multiplying this out, and yeah, well, we'll get to that, I guess. So I'm going to put this in my calculator. 1/3 times 7,419. And, oh, it came out a whole number. That's good. So when I put this in my calculator, I get 2,473. But the answer is not 2,473. The answer is 2,473. I'd say students. You could say people. It's the same thing. Students are people. And that works. All right, and that was nice, just being able to use a calculator to solve that one again. And we even showed work. Like some of you guys are, well, where'd you show your work? I did it right there. Just by interpreting the word problem into a math statement like I did there. That's work. That's work for me.